in example 8 and the last one in the point of regression, a repair workshop find it is having a problem with a pressure gauge it uses. It decides to have it checked by a specialist firm. The following data was obtained. You can see the reading of the gauge in X bar 1.0, but of course they believe that the correct reading was Y 0.96. When the gauge was reading 1.4, the correct reading is supposed to be 1.33, all the way until when it is reading 3.8, the correct reading is taken to be 3.75. These are the standard values that you're supposed to use in answering the question, and part A of the question show that SXY is equals to 6.776. This is simply a proof question. And of course, as much as we know, SXY is given by sigma XY minus sigma X sigma Y over N. And in this case, sigma XY according to us is 52.04 minus sigma X, which is 19.2, multiplied by sigma Y 18.86, everything over 1, 2, 3, 4, 5, 6, or rather 1, 2, 3, 4, 5, 6, 7, 8, everything over 8. If you ever do that using your calculator, you realize that it's going to be 6.776, hence shown. That is the first part, and the second part of A, then find SXX. And we all know that SXX is given by sigma X squared minus sigma X squared over N. And if you substitute this in place, sigma X squared is 52.8, is going to be 52.8. So 52.8 sigma X squared minus sigma X, which is 19.2, square that part, everything over 8, and then you realize this is going to be 6.72. You can confirm that. Part B, it is thought that a linear relationship of the form of y is equals to a plus bx could be used to describe this data. Part B of the question, it is believed there's a linear relationship in the form of y is equals to a plus bx. This brings about part B of the question. Use linear regression to find the value of a and the value of b, giving your answers to one decimal place rather. We all know in this particular equation of regression, b is always given by sxy over sxx. And now that we have those values, so we simply substitute to be equals to 6.776 all over the value of this 6.776 is the value of sxy, that part, and 6.72 is the value of s, this is sxx, which is 6.72. And if you do that easily, you will realize that this is our b is 1.0083. Fine. Having realized our b, how then do we get our a? Generally, our a is given by the mean of y minus b multiplied by the mean of x. But we don't have the mean of y, but we have sigma y. So our a is going to be sigma y 18.86 divided by 8. That arrangement gives you the mean of y, minus the value of b, 1.0083, multiplied by the mean of x, which is gotten from the sigma x divided by the number of times, which is 19.2 over 8. And if you do that, then you will realize that what you're going to have is our a, which is negative 0.0625, negative 0.0625. That is our value of a. If you look at part C of the whole question, let's just answer it here now that we have these values. Part C of the question is asking us to draw a scatter diagram to represent this data and draw the regression line on your diagram. The scatter diagram. Scatter diagram, of course, we're talking about the value of y against x. The y runs from 1 all the way to 4. So if you have 0 there, 1, 2, 3, 4. And then this one is running again from 1 to 4. 1, 2, 3, and 4. If you look at this one, this is 1, 2, 3, 4. And this is 1, 2, 3, 4. And this is the correct reading, which is y bar. This is y bar. And this is the reading on the gauge, which is x bar. The reading on the gauge. When the gauge is reading 1.0, the correct reading is supposed to be 0.9. When the gauge is reading 1.3, the correct reading should be 1.4 rather. The correct reading should be 1.3, somewhere there. When the gauge is reading 1.8, 1.75, 1.8, 1.75, just around there, 2.2, 2.14, 2.2, 2.14, and all the way to 3.8, 3.75, 3.8, 3.75, somewhere. So you can see we have kind of a straight line graph. It's kind of a straight line graph. And having done that, draw a scatter diagram to represent this data and draw the regression line on your diagram. So this is more or less like what we are expected to do in part C of that question. And part D, we are expected to answer a question which says the gauge shows a reading of 2 bar. Using the regression equation, work out what the correct reading would have been. The gauge shows the correct reading. Remember, first of all, we realize that our B is supposed to be 1.0083, and our A, what we've just wrapped here, is supposed to be minus negative 0.060625, and Y is supposed to be A, which is minus 0.0625 plus 1.0083x, and of course correct one decimal place. Then this one's supposed to be y is supposed to be 1.01x minus 0.0625. This is the equation of regression of y on x. So when the gauge shows a reading of 2 bar, using this equation, then work out the correct reading of the bar. So the correct reading, of course, is y. So we are talking about 1.01x, which is 2, minus 0.0625. And you realize that having done that, then y gives you a value of around 1.95. It is not advisable to round off when we are substituting the value of 2 here. So it is important to even do it using the original value that we realized, which is 1.0083 multiplied by 2 minus 0.0625. And y becomes 1.95 bar. You can confirm that. And the reason why you should not use a rounded up figure when substituting in 2 in this particular equation is because the answer you're going to get in the final end is going to be to incur a bigger error. So the final answer, or the correct reading when the gauge shows 2 bar, is obviously 1.95. All right.